Half of my time as a DevRel is answering the same question: what the Cartesi execution environment is and what it actually does. So I answered it 3 times at once, 3 levels deep, for a 10-year-old, an engineering student, and a PhD. Here's what's landed. You pick the one that fits. Imagine you and your friends made up a game where you can win real money. But here's the problem. You need someone to count the score. And everyone has to trust that person. What if no single person counts? What if a special robot computer counts instead? That's basically what a blockchain does. It's a shared notebook that everyone can see and nobody can change what's already written. But here's the tricky part. That shared notebook isn't great at doing really hard math. It can add and subtract, sure. But if your game needs complex calculations, like figuring out who gets paid how much, the shared notebook starts to struggle. And what if you didn't have to be stuck with that basic calculator? What if you had a full computer that everyone could still verify and trust? That's the idea behind Cartesi. Let's level up and see how it actually works. DeFi runs on smart contracts, and smart contracts run on the EVM, the Ethereum virtual machine. The EVM uses integer arithmetic only. No floating point, no standard library, no file system, and every single operation has a gas cost. A tax to be paid for the computation. The more complex your logic, the more your users pay. A pricing engine for option needs exponential and logarithmic functions. The EVM cannot compute natively. You end up with imprecise and expensive computation. Everyone cut corners. Options protocols skip continuous time pricing entirely. Cartesi's answer is to replace the execution environment, not to patch it. The Cartesi machine is a full RISC-V virtual machine running a Linux OS. Your app logic runs inside this machine. You write your DeFi backend in Python, Rust, C++, Go, whatever you like. You use libraries like SciPy for numerical methods, SQLite for state, and any library you've ever worked with. The developer experience shifts completely. From fighting the EVM constraints to writing normal software that happens to settle on-chain. But wait, if the computation happens off-chain, how can we trust the result stays trustworthy? This is something we will deep dive some other time. The EVM is a stack-based virtual machine operating over 256-bit integers, intentionally minimal by design. No floating point, no transcendental functions, no persistent heap beyond a flat key value store. Every full node re-executes every transaction to validate the chain. That's what makes consensus trustless. But that means your application's computational cost is replicated across the entire validator set forever. Cartesi separates these 2 concerns. Computation runs inside the Cartesi machine, a RISC-V virtual machine running a full Linux environment, entirely off-chain. Only the proof of the computation is committed on-chain. The shared chain is no longer the execution substrate, it's a settlement layer. The ISA instruction set architecture of choice matters more than it might seem. RISC-V is an open, formally specified instruction set with a mature 2-chain ecosystem. GCC, LLVM, glibc, the full Linux software stack. This means any language with RISC-V target compiles and runs inside the Cartesi machine without modification. Python, Rust, C++, Go, Haskell. The execution environment is genuinely general purpose. Compare this to a custom VM or a custom ISA. A custom ISA requires custom compilers, custom tooling, custom security audits. It creates a permanent maintenance burden and narrows the developer audience to those willing to learn new abstractions. It creates a permanent maintenance burden and narrows the developer audience to those willing to learn new abstractions. RISC-V inherits decades of compiler optimization and 2-chain maturity. The Cartesi virtual machine was made auditable at the instruction level. This allows us to run fraud proofs to guarantee computation was executed correctly. Whether you're scoring a game with friends, building a complex pricing engine, or auditing instruction sets, the bottleneck is the same. And Cartesi's real-world computer is the answer. That was 3 levels deep on Cartesi's execution environment. Tell me below which version made the cut for you. Next up, we're going 3 levels deep on app-specific rollups. Same challenge, same format, different topic. Follow along.